In this recording, I will show you how to find the inverse for a 2 by 2 matrix. There's many ways to do this. I've done other videos where I use the row manipulation to find the determinant of a 3 by 3 matrix, which is a longer way. Here, I will just show the straightforward method using the 2 by 2 formula, and if I do other videos, I'm sure I will cover I will go back at some point and cover this using the row elimination. You could also you could do cofactors and cominors. There's many ways to find the inverse. um, okay, so let me do a first. So the way that this works to find the inverse of a 2 by 2, if it's a, b, c, d, the way you would do this is first you would find the determinant of this 2 by 2. So the determinant, of course, will be ad minus bc for a 2 by 2. And then what you do is you switch the first diagonal, this diagonal, so it becomes dA, and you multiply these by a minus sign, so we get minus c minus b. Let me just make sure I didn't do it backwards. I'm pretty sure this is it, but let me confirm. Yeah, okay, good. So and now what you do is you take this matrix that you got and you divide each cell of the matrix by the determinant. So if this is matrix A, for example, then A inverse becomes, for instance, becomes, so I divide each cell 1 over AD minus BC times each one of these cells, D minus B minus CA. So let's apply that to matrix A here. Let me do it here on the side so we can have this handy. Okay, so A is 0, 3, or it's okay, we'll do it below, 0, 3, 4, 0. So now I'm getting to the question. 0, 3, 4, 0. And the determinant of this matrix would be 0 minus 12, which will be minus 12 because 0 times 0 minus 4 times 3. And now, like I said, A inverse will be 1 over 12, and then I would switch these two. But it's not going to make a difference if I switch, because if this pad comes back, okay, because they're zeros, and then I would multiply this by minus 3, so minus 4, 0, and so A inverse becomes 0 minus 3 over 12 is minus 1/4. This is minus, I multiply each one of the cells by that. This is minus 1/3, and this is 0. So this would be the first answer. This is A inverse. Let's go to B and do the same thing. I'll skip B because B is actually B and C are the same exact thing. So I'll just do it really quick in one step. So B inverse will be, here we have the determinant is 2 times 2, 4, minus 0 is 4. So I would have to divide by 4, and I would flip the 2's. When I flip them, they remain the same, and negative sign on 4 and 0, which makes this minus 4, 0, right? Yeah, and so I would get A inverse to be half. 2 over 4 is half. 0 minus 1 half. So this is B inverse. And if I finally do C inverse, 3, 4, 5, 7. So the determinant is 3 times 7. 21 minus 20 is 1. So I would divide by 1. And I would switch them. So 7, 3. And minus 4, minus 5 here. Okay, so this obviously dividing by 1 will leave it the same. So this would be C inverse. This is one of the ways to find the inverse of a matrix. And of course, you get a matrix when you flip these matrices. I'm supposed to put a dash underneath this just to indicate that it's a matrices. That's how I usually distinguish the matrices from scalars or vectors. Although you could express vectors with matrices. That does it.